Now we go to chapter 7. On chapter 7, most of the problem we deal with is to solve for an oblique triangle. Right, so let me write out the section. Right, solving oblique triangle. Oblique triangle is a triangle that is not right, meaning that there's no right angle. So oblique triangle is a triangle that the angle no right angle. So a triangle that has no right angle. Right. And to solve for a triangle, meaning that we're going to find all the missing information about the triangle. Usually a triangle will have 3 sides and 3 angles, and so we need 3 information in order to find the missing 3 information. So this will be the 3 cases. For unique triangle. Right. So once again, to solve for a triangle, we need 3 information to find the missing 3 information for the total of 6. 3 angles and 3 sides. Right. The following sets of given parts, and by parts I mean it is either a side or angle. Determine unit triangle. Case number 1, angle side angle. It will be easier. I just draw it out. So what we are given is an angle and then a side and then another angle. So when we are given these 3 information, we have a unique solution. So this is the side, 2 angles at the side in the middle. 2 angle side. So we may be given 1 angle, another angle, and then a side. When we have these 3 information, we have a unique solution as well. So actually this is very easy to see, because all 3 angles add up to 180 degrees. If we know 2, we certainly know this one as well. When we know this, the side and angle, that is just angle side angle. Right, next, side. And obviously this Did I miss? Okay. Sine, angle, sine. So we have a triangle. We know a sine. An angle in the middle. And then the other side. So sine, angle, sine. When we know these three information, we will have a unique solution. And then sine, sine, sine. Obviously, we know all three sides. So 1, 2, and then 3. While we know all three sides, we have a unique solution. Right. The case of sine, tan angle may not determine a unique solution. So this case, the case of sine, sine, angle, don't say it backward. May not determine a unique triangle. Right. So bottom line is we are given 3 information and we try to find the missing 3 information. So we need 3 to find the other 3. Right. Right. And in chapter 7 there are 2 ways to do it. The law of sine and the law of cosine. So first, the law of sine. This I'm going to draw out a little more carefully. Right, let me write this down. In any triangle, works for the right triangle as well. So in a typical triangle ABC, the normal convention is that we use the little letter for the sine opposite to angle A, and the little c opposite to angle C, and the little b opposite to angle B. And with that convention, on any triangle, we have the law of sine. Sine of A over A equals sine of B over B equals sine of C over C. Well, this is simple enough, right? So sine of an opposite angle divided by sine, the ratio, that ratio is constant, right? We can also flip all of this. Right. So either that or that. Opposite angle and size have to be in the same fraction. Right. And notice once again the ratio of the sine of an angle and the opposite side is a constant. So because of this, the law of sine, we use the law of sine when we know a pair of opposite sine and angle. use law of sine. When a pair of opposite sine and angles are known. Meaning that we have to know one of the ratio. Right, so simple enough. Sine of an angle over the opposite side, that ratio is the constant. Right, so before we actually go to the problem, let's review some important facts about triangles. Right, first, the sum of all three angles in any triangle is 180 degrees. So I'm just going to say A plus B plus C equal to 180 degrees. Right. So in triangle ABC, the angles add up to 180 degrees. Second, triangle inequality. When we add two sides, it has to be bigger than the other side. Doesn't matter what two sides we add, it's always greater than the remaining side. Just take two, add them up, it's going to be bigger than the other side. And then this will come in handy later. I just say bigger angle. Face will face longer side. Right. So these three important facts will come in handy when we solve triangle. Right. Now we just go to an example. By the way, I put the calculator slightly bigger because we use the calculator a lot. Solve triangle ABC. We are given angle A equal to 62 degrees. C is 14 feet. And angle B is 74 degrees. Right. Now, it will be very useful if we just draw the triangle. Doesn't have to be exact information we have. Just draw a kind of a generic triangle, so at least we have the idea of what we are looking for. Right. Right, we have angle ABC. What we are given, angle A, 62 degrees. If there's degree, make sure we have the unit. Angle B, 74 degrees. And the sine C is going to be opposite to the angle C. Now to distinguish between the angle C and the sine C, just make it with kind of a loop on the C, and then for the sine C we just kind of regular C, that is 14 feet. Right, so we draw a triangle, and I would recommend that not only we do that, we write down all the information we have. Angle A 62 degree, angle B 74 degree. We do not know angle C. But we do know sine C is 14 feet. We can just drop the unit feet when we do the calculation, but the degree we cannot do that. So we are not given the sine A, we don't know that, and we don't know sine B. Right, so summarize the problem, draw the sketch to get the idea. Right, now, so what can we do? Right, first, obviously, if we know two angles, we know the third one. So let's start with that. Okay, A plus B plus C equal to 180 degrees. From here, we can solve for angle C. Is equal to 180 minus 62 and minus 74. 180 minus 62 minus 74. Right, this is 44 degrees. Right. Now, I'm going to put 44. Right, what we have now is we have an opposite angle and sine, a little c and big C. That is where we know how to use the law of sine. Right. The law of sine. Sine A over little a, sine B over little b, and sine C over little c. Right, now put all the information we have. Sine of angle A 62 degree. Do we know sine A? No. We do know sine of the angle B, but do we know little b? Still no. Angle C is 44 degrees, and little c 14 feet. I just dropped the feet, 14. Right. Now, and we have a pair of opposite sine angle, so we know this ratio. Now this is very simple. All we do is we're just going to group this, cross multiply, and then we solve for b. So cross multiply, we have b times sine 44 degrees equal to 14 times sine of 74 degrees. And then to solve for b, we will take 14 sine 74 over sine of 44. Right. Most important, in this triangle, solving triangle, all the measures have to be in degree. So make sure we hit mode and in degree for this chapter 7. That is very important, right? So alpha y equal to, that's the fraction, 14 sine of 74 divided by sine of 44. Right, we have 19.37. And little b, the unit should be feet. Right. Usually you keep 2 or 3 decimal places, whatever the question tell you. Okay. Make sure in degree mode. Right. So we take these two ratio. We found this. Little b 19.37. Right. And then the remaining is a. To solve for a, we will take this ratio, the first and the last ratio. Yeah. So take the first and the last, and then cross multiply a times sine 14 degrees a times sine of 44 degree equal to 14 sine of 62 degree and divide by sine 44. 14 sine of 62 divided by sine of 44. Right. Alpha y equal that fraction of 14 sine of 62 divided by sine of 44. We have 17 point say A0 feet. 17.80 feet. Right. So that is our answer. And always do this check. The biggest angle will face the longest side. The smallest angle will face the shortest side. So that check. This is always nice to do the check like that at the end. Right. And finally, in this scenario, what we are given is an angle, a sine, and an angle. So this is the angle, sine, angle scenarios. And we have a unique solution like that. Right. So it's pretty simple. Kind of straightforward. Just have a triangle, find the missing information, where whenever we have a pair of opposite angle and sine, that is a law of sine. Right, so that's the first example. Right, next we have show the triangle. Right. In this case, we are given a sketch. Right, so what we are given. Triangle ABC. We are given angle A 81 degrees, angle B 83 degrees, and then this side is 7 centimeter. This side is opposite to angle B. So that will be a little b. Right. As always, I try to write out what do we know and what don't we have, or what we need to find. Angle A, 81 degrees. Angle B, 83 degrees. C is not mentioned, so we don't know that. Do we know little a? We don't know that. Do we know little b? Yes, we do. 7. Okay. So try to keep the color code. And then obviously, the sine A we don't know. Right. So that's what we have. Right. Before we do anything, when we look at this problem, what we see is a pair of opposite angle and sine, big B, little b. This will be law of sine. Right. Straightforward. When we have that, that is the sign that we use law of sine. Opposite angle and sine. Right. But even better, the first thing we should find is this angle here, because we know two angles and they add up to 180 degrees. So we can find the remaining angle easily. So A plus B plus C, 180 degrees. So we find angle C, 180 minus 81 minus 83. 180 minus 81 minus 83. So that's very simple. 16 degrees. Right now we just need to find the sine A and sine C. Right. So once again, knowing the opposite sine and angle, big B, little b, that is the law of sine. So right. Just going to write out directly without writing the law of sine again. So sine of A now let's just write the formula one more time. Sine A over little sine A, sine big B, little b, big C, little c. Right. Sine of A, big A, 81 degrees. Little a, don't know that. Sine of big B, 83 degrees over 7. I dropped the unit. And then sine of 16 degrees over little c. Right. Once we have a pair of opposite side angle, we know ratio, and we're going to use that. These two ratio, cross multiply to solve for c. C times sine 83 degrees equal to 7 times sine of 16 degrees. Cross multiply, C equal to 7 sine of 16 degrees divided by sine of 83 degrees. right? And we just do that. Alpha y equal to, or we don't even need to do that, 7 times sine of 16 divided by sine of 83. 1.94 centimeter. Right. Now, if we take this ratio, the first two ratio, and cross multiply, a sine of 83 degrees equal to 7 sine of 81 degree. And to solve for a, we take 7 sine 81 divided by sine of 83. Sine of 81 divided by sine of 83. 6.96. Let's place 97 centimeter. Right. So we have angle, the sine A 6.97 and then 1.94. Right. Once again, biggest angle, longest sine, smallest angle, shortest sine. So that sounds right. And also, the calculator should be in degree mode. Right. So, we just like that. Once again, when we have an opposite sine and angle, when we have this, that is the law of sine. Right. More examples. Show triangle ABC. A is 46, B is 100, and little a is 10 meter. Right. Just draw a triangle in general. I don't need to draw an exact triangle. Just draw something so we can visualize. Right. So what we are given? Angle A 46 degrees. Angle B 100 degree. And then little a. The little a is opposite from the big A. 10 meter. Right. Let's summarize. Angle A 46 degree. Angle B 100 degree. Angle C, don't know that. Little a 10 meter. Do we know B? Nope. and we don't know C. Sorry, this is C, and this is B. Right. So once again, opposite pair of angle and sine, big A, little a. So that is the law of sine without doing anything. Right. But first, since we know two angles, just find the third angle. Angle C, 180 minus 46 minus 100. We don't even need a calculator for this, but $34, right? 34. $34, right? And then put it into law of sine because we have an opposite angle and sine. Right. Of course, the law of sine is that we don't even need to write the law, the rule. Just write for this number. Side of angle A, 46 degrees. Opposite to that, we have 10 meter, little a. And then go to B, sine of 100 degrees over little b, which we don't know. And then sine of 34 degrees over little c, which we don't know either. Right, so take the ratio of the first two, cross multiply, and solve for b. B sine of 46 degrees equal to 10 sine of 100. Right, and then solve for b, 10 sine of 100 over sine of 46 degrees. Right, yeah, in degree mode, 10 sine of 100 divided by sine of 46. Have 13.69. The unit is meter, so let's be consistent with that. 13.69. On the test or on the homework, make sure read the question carefully. They will tell you how many decimal places do they want, usually. Right, so that. And then if we take the ratio of the first one and the last one and cross multiply, C sine of 46 degrees equal to 10 sine of 34 degrees, and then solve for C, 10 sine of 34 degrees divided by sine of 46 degrees. Right, so 10 sine of 34 divided by sine of 46. 7.77 meter. Right, final check. Biggest angle face the longest side, smallest angle face the shortest side. So that check. It's always nice. At the end we need to check that. Right, so we have a work problem here. Right, we have two lookout towers A and B, 5.2 miles apart, with A due west of B. A column of smoke is sounded from the A with the bearing of that, and B is that. How far is the phi from B to the nearest foot? Right. Right. Okay, just look at the problem here. Right. I'm not write the problem out loud. We just need to denote what we know. Right. Two lookout towers. A due west of B. So A is on the left, B is here. And they are 5.2 miles apart. A column of smoke is sighted from A with the bearing of north 75 degrees, 75.2 degrees on the east side. So the smoke is somewhere in here. From A. So there's a smoke here. Let's say that is a C. And the bearing is north. I wrote that terribly, right? 75.2 degrees. Sorry. The graph here is a lot better. Sorry, that should be a lot bigger than this. Right. And then from B, it doesn't really matter. What matter is just put the information in. Right, from B the angle is north 53.4 degrees on the west side. So north 53.4 degrees on the north, on the west side. And how far is the phi from B? Right. So we only asked to find this one. So for triangle ABC, what we are given and what we need to find. Try to summarize like this: little a, little b, and little c. Right. Do we know angle A? We know that big angle, but the true angle A, the actual angle A is this angle here. So this is the angle A. Good thing is this is between the north and the east-west, so that is 90 degrees in total. 90 degrees minus that give us this angle A. So 90 degrees minus 75.2 is 14.8. And then angle B, same thing. Subtract from 90 degrees. Subtract this from 90 degrees. We have this angle here. So 90 minus 75.2. And then 90 minus 53.4. 36.6. That is angle B. Right, 90 minus 75.2 and 90 minus 53.4. Right, and we know opposite to angle C is that, and this is the sine C. That's what given. The question is find BC. Meaning that we need to know A. Because that opposite to angle A. So we only need to find this here. Right. So we don't have a pair of opposite sine angle directly. However, this should be obvious when we know two angles. Find the last one. (180° minus angle A 14.8 and minus angle B 36.6. Right. So I have 180. Now the nice thing about this calculator is that when I subtract, I just go up, highlight the number, hit enter, and then subtract, highlight the number, hit enter, and just copy and paste down to it, and then we have 128.6. (128.6°). Now we have all angles. More importantly, a pair of opposite sine angle here. That is the law of sine. So sine of angle A 14.8 over A. Don't know that. We don't even need this because we only need to find A, but I write that anyway. 36.6 over B, and sine of 128.6 divided by 5.2. Right, only need to find A though. So take the first ratio and the last ratio. And cross multiply. A sine of 128.6 equal to 5.2 sine of 14.8. So to get A, we have 5.2 sine of 14.8 degrees. divided by sine of 128.6 degree. Right, 5.2 times sine of 124, sine of 14.8 divided by sine of 128.6. Yeah, I think it's better put in fraction form. Right, anyway, 1.6999. Right, that's good and all, except the question want the answer in foot. Right, and we use the conversion factor. 1 mile is 5280 feet. Mile and mile cancel out, and we just have this number times 5280, and we have 8,974 to the nearest foot. Okay, that fit. So it's 8974 feet. Right, so that's simple enough. Right, once again, the law of sine is useful when we have a pair of opposite sine angle. Right, with that we just go to the next section, section 7.2. We're still using the law of sine here, but this is the special case. That special case is what we have earlier, is the sine, and angle, because this scenario we may or may not have a unique solution. Section 7.2, the law of sine. The ambiguous case. Right, definition. Right, the ambiguous case. Definition. Right. Right. If we know the length of two sides, and the angle non-included angle. This case, this is called the sine, and angle scenario. Then we can have no solution. 2. One triangle. And 3. 2 different triangle. And we have 2 scenarios. One, we know when the angle is acute and when the angle is obtuse. An acute angle is given. Right, so what we know is we are given a sine B and then also a sine A. And then the angle A is also given. So we know this angle A, sine B, and then sine A. Right. When we have like that, this side is too short to form a triangle. So this we have no solution. Because that is too short. So the third side is shorter than the height. So it will not touch to form a triangle. It doesn't matter how it swings. Let's say we have one side here, another side, and the third side is too short to form a triangle. If it's long enough, then yes, it will form a triangle. But if it's too short, it will not touch this side to make a triangle. So no triangle here. Now, it all depends on what we are given at the sine A. If the sine A is just right here, then we have one solution. So this is one triangle. On a rare case, and I should not say rare, we may have a sine A where it swings both ways. So we may have a triangle like this and a triangle like this. Both of them have the sine A, right? So in this case we have 2 triangles. And if the third side is way too long, we also have one triangle. If this is way out here, it will be one triangle as well. So, if we know sine A and the sine B is way too long, in that case we only have one triangle. So depends on, sorry, this should be B. And that should be A. Depends on the size of A. We may or may not have a triangle. But even have 2. If this is too long, we only have one solution. Right. The case where an obtuse angle is known. So we know angle A, and it is obtuse. But if the sine A is too short, once again, it will not form a triangle if it is too short. If it is long enough, we will have a triangle. If it is long enough, it will form a triangle. Right, now let's go to an example. Right, now the best way to do it is not actually draw all of this, just react to what problem give us, and then just take care one at a time. And again, when we have a pair of opposites, angle and sine, that is the law of sine. 2. Example. A. Solve the triangle ABC. If C is 62 degrees, A is 50, and little c is 100. Obviously, when we read the problem, big C, little c, that is the law of sine, without question. Right. Now, even that, we may or may not have a solution. So let's at least draw a sketch. Right. Angle C is 62 degrees. And little a is opposite to big A, 50. And little c opposite to big C, 1. Solve the triangle, meaning that we find all the missing information. Right, let's write it down. We don't know angle A, don't know angle B, angle C, 62 degrees. Sine A, 50. B, don't know. And then little c is 100. Right. Obviously, when we have this, we need to use the law of sine. When we are only given one angle, we cannot find the other two. By subtracting 180, it doesn't help at all. Right, so law of sine. Because we have this, a pair of opposites, angle and sine, big C, little c. So, law of sine. Sine of A, we don't know big A. Little a, 50. Sine of big B, don't know that. And don't know little b either. Sine of big C, 62 degrees over 100. So that's what we are given. Obviously, sine B and B, we're not going to use this because we don't know either of them. But we take the first one and the last one, we can cross multiply. Right? So, cross multiply 50 sine of 62 degrees equal to 100. Sine A. Right. And then to solve for sine A. Is 50 sine of 62 degrees over 100. Sine of 60, sorry, fraction 50 sine of 62 divided by 100. It is in degree mode, so it's good. So right, so we have sine A is equal to that. Right. Make sure in degree mode. That's good. All right. Now to get back to the angle, back into chapter 6, when we have sine A equal to that, there will be two solutions. The first one is A equal to the sine inverse of that ratio, and the other one is the supplement to that. Right. So that's why we might potentially have two solutions. Of course, there might be plus 360 degree multiple 360 degree to have coterminal angles, but we don't need to do that. All the angles here in the triangle so have to be less than 180. Right. So if we take sine inverse of that, we have 26.2 degrees. And then the supplement to that, -180 minus that, 153.8. Right. So when we have the sine equal to sine inverse, always two solutions. However, one of them may not work or none of them will work. Right. Let's put it back in these scenarios here. Let's see which one will work. Right. Now the A is 26.2. B still don't know. C is already given. A is 50. B we don't know. C is 100. Okay. The other case. Now, how about A is 153.8. Still don't know B. We do know angle C. Little a. Don't know little b. Little c is 100. Right. We might have two solutions. Right. We can subtract from 180 to find angle B. But before we go any further, let's take a look. Check real quick. We always check this. Maybe at the end, maybe somewhere in the middle. But what we have here is bigger angle. This angle is bigger than that. We expect the side is longer than that. This is the bigger angle, but the side is not. So this is not a solution. Because the bigger angle does not face the longer side. So that's why in this problem we don't have this case. This is all we have. And we'll continue from here. This doesn't work. Does not work. Because we need to have bigger angle. Faces longer side. And we don't have that here. So that doesn't work. Right. And then we continue with this case. This case still work. I will take 180 minus those two. We have B. Right. 180 minus 26.2 minus 62, 91.8 degree. And then finally we can find B. That is the law of sine. So write out the law of sine. Sine of 26.2 over 50 equals sine of 91.8 over B, sine of 62 over 100. Right, it's fair enough. We just take the ratio and the ratio will work. And between this and this, I would prefer to use the last two ratio. I prefer to use this one instead of the first two to find B. Right? Why is that? The reason I do that because 100 degrees. 100 is given. 62 degree is given. The 50 is given, but the 26.2. This number we found, and if we use 26.2 and like the calculator over there, we have some rounding error in that, right? So whenever possible, use the number that we are given, which is more accurate than the number that we calculated. Right, so we go with this. And so for B, cross multiply so B equal to 100 sine 91.8 over sine of 62 degrees. Fraction, right? 100 sine of 91.8, that divided by sine of 62, and we have 113.2. And now we check again. Biggest angle, longest sine, smallest angle, shortest sine. So that certainly check out. So that fact is handy. When we check that, we rule out this case. So this one we only have one solution. That one. Right. Like I said, of this kind of problem, we just react to what we have. Don't even need to draw the triangle. But when we have the sine equal to something, when we find the solution, there's always two solutions. The angle, the inverse, and then the other one is the supplement to the inverse. So the inverse and the supplement. Right. That I'll go to the next example. B. Show the triangle ABC. If we have big C, angle C is 40 degrees, little a 3.3, and the little c is 2.1. Right. And we just kind of react to what we are given. Right, C is 40, A is 2.3, little c 2.1. Right. Let's try draw a triangle to get the idea of what the triangle will look like. Just help visualize the problem. Right. Before we do anything, in this case, big C, little c, a pair of opposite sine angle. So this definitely a law of sine. Before we do anything, we can tell that right away. A pair of opposite sine angle, that is the law of sine. Right, C is 40 degrees. A, sine A is opposite to big A. And sine C is opposite to big C. Right. I always write out the summary. Angle C. And after all of that, I thought I have a hang of what we are given. Right. We don't know angle A. Don't know angle B. Only know angle C. Little a, 3.3. Don't know little b. And we do know little c. Right. Obviously, a pair of opposite sine angle, law of sine. Sorry, I mentioned that too many times. Sine of angle A over 3.3 equals sine of B over little b, and sine of 40 over 2.1. The middle ratio is useless because we don't know either of them. So let's cross multiply using the first and the last ratio. 3.3 sine of 40 degree equal to 2.1 sine A. And then we can solve for sine A. Excuse me. Sine A over 3.3 sine of 40 degrees divided by 2.1. Right. And then we just solve for that. Still in degree mode. You don't have to do that every time. Just that I've used the one on the computer. I don't know if for some reason it is reset by itself. Have 1.01. Right. Now if you notice, if you see this and you say no solution already, and you know that there's no solution already, then it's very good. But in general, when we have the sine equal to something, there will be two solutions that follow. The first one is the sine inverse. And the other one is the supplement of the sine inverse of that number. Right. Once again in degree mode. Sine inverse of don't need to copy that number. Just highlight, hit enter, and copy and paste, and we find the sine inverse. Right. So there's nothing wrong there. We said there's error in the domain. So remember, sine is the wave, right? It's bounded between -1 and 1. This is 1.1 outside of the range. So there's no solution. Because the sine inverse, that does not exist. So that for both of them have the sine inverse of 1.01. So in this case, none of them will work and we have no solution. Like I said, at first we don't know if there's no solution or not. What we do know, the only thing we know is we use law of sine, and when we do that, trying to find an angle, it doesn't work because neither of them works. Right. So in that case, we have no solution. I said nothing is known by when we look at the original problem. I said we just react to what we have, case by case. In this case, there's no solution. Right. If anything is bigger than 1 or anything is lower than -1, there will be no solution, because sine has to be between -1 and 1. Right. I'll go to next example. C. Solve the triangle ABC. If A is 42 degrees, little a is 55, and little c is 62. Right. Big A, little a, law of sine. Right. Let's draw a triangle. Right. Angle A is 42 degrees. Little a, 55. And little c. Right. Also, one thing to note that on all of this scenario, what we have is, we call this the sine, and angle scenario. So when we are given two sides and not the angle in between, that is the ambiguous case. If we know the angle in between, there's a unique solution, but the angle is not in between the two sides. There's this ambiguous case. So when we know two sides, but the angle is not in between, prepare for the ambiguous case. Right, let's summarize. Big A, 42 degrees. Little a, 55. Little c, 62. We don't know b, or little b, or big C. Right. So once again, law of sine. Sine of 42 degrees over 55. Sine of big B over little b. Sine of big C over little c. We know little c is 62. Right. Then we can check the first and the last, because sine B and B, we don't know either one of them. That will be useless when we calculate this. Cross multiply 62 or 55 sine C equal to 62 times sine 42. So to solve for C, right, degree mode, yep. Alpha y equal to 62 sine of 42 over 55. Zero 0.7543. Right. Now, when we have sine equal to something, there will be two scenarios. The first one is we have the sine inverse. And then the other one is the supplement of that. Right. I'll be a little more careful here. Then you got the feeling that it is two solutions on this one. Besides, we have two examples. One of them has no solution. One of them has one solution. It would make sense if we have a problem that has two solutions. Right. So. Right, what is the sine inverse of that? Second sine inverse of that ratio, which is 48.96. We take the supplement to this 180 minus that. 131.04 degrees. Right. So which one works? Maybe both, maybe none, maybe only one of them. Right. For both of them, let's put both of them into this example. Right. So what we have, once again, A 42 degrees, little a 55. We don't know B or little b. We just found out the big C is 48.96 degrees. And little c we know 62. Right. Let's check real quick. Bigger angle, longer sine. So this one may work. This one works. Because when we have everything, we put it back and check. But for now, that certainly checks. Bigger angle, longer sine. That's good. How about the other one? Now we found C. By the way, sometimes when we do this and we get C, like for example 150 degrees, we add them up, and there's no room for the third angle, so we know that is not going to work either, right? Like the last case when we check 153 and 62, those two add up is more than 180. That's why we know it doesn't work either, right? Because all the angles have to be 180. If it's more than that, it doesn't work. Right. Along with the bigger angle have to face the longer side. So that's what we can check. In here, they add up less than 180, which is good. And bigger angle, longer side, that's also good. So they are, both of them are okay so far. Right, now when we have C, suddenly we can find the remaining angle B. A plus B plus C is 180 degrees. So angle B 180 minus 40, just write it down. Minus 42 minus 48.96. We have 89.04 degrees. 89.04 degrees. Now just need to find little b. Right. I still use the law of sine here because opposite side angle. So sine of 42 degrees over 55 with sine of 89.04 little b and sine 48.96 over 62. Once again, we are given 42 and we are given 45. This number 48.96 we calculated, so it's not as accurate as the number given. So I will use if I have a choice between using the number that are given and the number that are calculated, always use the number that are given because that's more accurate. Right, cross multiply b sine of 42 degrees equal to 55 sine of 89.04 degrees, and we solve for b. 55 sine of 89.04 degree sine of 42 degree. 55 alpha y equal to 55 sine of 89.04 divided by sine 42, 82.18. Right, biggest angle, longest sine, smallest angle, shortest sine. So that check. So we have one solution here. That solution works. Now, back to the other case. A plus B plus C. So we solve for B. (180) minus 42 minus 131.04, 696. And then we do the same thing. Sine of 42 degrees over 55 equal to sine of 6.96 over little b. And then we're not going to use that ratio anyway, right? So b sine of 42 degrees sine of 6.96 degrees times 55. So B equal to 55 sine of 69 6.96 or sine of 42. $55 sine of 6.96 was sine of 42. 9.96. Right. One thing I forgot, when we do this calculation, we should go up and then use the whole numbers rather than use the rounding error, but that's fine. So let's check. Biggest angle, longest sine, smallest angle, shortest sine. Let's check. So in this case we have two solutions. Right. So where the case of sine, and angle, when we know two sides but not the angle in between, that's where we have the ambiguous case. We might have more than one solution, or no solution, or one solution. Bottom line is, when we have a pair of opposite angle and sine, we use the law of sine. Right. The next section is the law of cosine. The law of cosine. Right. So the law of cosine I'm just going to draw a triangle, kind of generic. Opposite to big A is little a, opposite to big B is little b, opposite to big C is little c. And in any such triangle ABC, with sine little a, little b, and little c, when we have those, the law of sine, law of cosine is a squared equal to b squared plus c squared minus 2bc cosine a. Of course, cosine, law of cosine, obviously we're going to have cosine. B squared equal to a squared plus c squared minus 2ac cosine b. C squared equal to a squared plus b squared minus 2ab cosine c. So that is the law of cosine. Right, so there are three of them. Now, by the way, did you see this one before? That is the Pythagorean theorem, right? So we could say that the Pythagorean theorem is the special case of the law of cosine, because cosine of 90 degrees is equal to 0. So we have the Pythagorean theorem if an angle is a 90-degree angle. Right, now, how to memorize this? We could start with A, B, or C. It doesn't matter. A square, B square, C square. When we have those square, the other two have to be a different letter, right? If we have A square, then B and C. If we have B, A and C. If we have C, and A and B. So whatever square is the other two square. The angle though is always the same. If we have A square equal to, end up with cosine A. B square cosine B. C square cosine C. Those two letters, the same as those two letters. Right. Most importantly, when do we use the law of cosine? We use the law of cosine when, so it goes without saying, I mentioned before, when we have an opposite angle and sine, that is the law of sine. When we don't have that, we use the law of cosine. So we use the law of cosine when we cannot use law of sines. Meaning that when we don't have a pair of opposite angle and sine. So that is where we use the law of cosine, is where we don't have a pair of opposite angle and sine. Right, let's look at the first example. So triangle, if little a is 4.7, little b 5.2, and little c is 10.1. Let's draw the triangle first. Right. In this triangle, we are not given any angles. So we don't know A, don't know B, and don't know C. But we are given all the size. Little a, 4.7. Little b, 5.2. And little c, 10.1. Right. So obviously, since we don't have any angle, we don't have a pair of opposite angle and sine. So the law of sine will not work. Don't have the opposite angle and sine. So use the law, cannot use the law of sine, so use the law of cosine. There are three of them. So which one do we use? We have all three of them, right? Actually, it doesn't matter which one we use. But from the experience, when we're doing this, I always use the one with the biggest angle. So I'm going with c squared. Right? So we go with c squared. Now if we use c squared, we're going to have the sum of the other two square minus the other two we start with angle. Start with little c. We should end up with the cosine of angle big C. Right. Like I said, if there's the choice of the law of cosine, I will choose the one with the biggest sine, therefore the biggest angle first. Because later on I have to find A or B. I don't have to worry about the inverse. I don't have to worry about the two scenarios here. Because when we find the biggest angle, we will not have one of those two cases. Right? So once we have the biggest angle already out of the way, the other two angles have to be acute. Cannot be more than 90 degrees. Think about it. Once we found the biggest angle, the other two angles have to be less than 90 degrees. The biggest angle could be anything, but the other two angles, the other smaller angle, cannot be more than 90 degrees. That one for sure. Therefore, even though if we have to find the sine inverse, there's only one solution because there's no supplement to it. Right. Do this. Right, so what we know the law of cosine, right? Which is that. Now put all the information we have here. 10.1 square for C, A square 4.7 square, B square 5.2 square, minus 2 times 4.7 and 5.2. By the way, this is not the way we should do it. When we put everything here, obviously we can show for cosine C, right? But let's not do that. What I prefer is subtract A square and B square. So we write C square minus A square minus B square equal to negative 2 AB cosine C. Right, don't put the numbers there yet. And now we know everything but the angle C, so we isolate that, divide by negative 2AB. So we have cosine of C equal to C square minus A square minus B square over negative 2AB. Right? And then we can put in the numbers. C square 10.1 square, A square 4.7 square, B square 5.2 square, over negative 2, 4.7, 5.2. Right, I can even do this. We cannot use the lower case, so we can only use the upper case here. So I will do 4.7 store alpha A, that A. 5.2, there's no lowercase, so that's why we have to use uppercase here. C 10.1 store alpha C. Alright, so we store the numbers into ABCs, and then we're going to do this. Alpha y equal to, right, we have C square alpha C square minus alpha A square minus alpha B square over negative 2 A B. Right. Negative 1.08 2. Right. Now we have cosine equal to that. then we can find the cosine inverse for C. So when we have, now this is in section 6. Chapter 6, when we solve for C, C could be equal to cosine inverse or the opposite to that. However, we're not going to have this because what we have an angle here, it have to be a positive number, so cannot take a negative. Right, is that still in degree mode? Right, it's good. Cosine inverse of that number right, so we don't have that, and this one is no solution. Why is that? Now think about this. If we are given one side is 10.1 and the other one 4.7 and then 5.2, this two, when we add up, is not as long as 10.1, so those 2 points will not meet, and there's no solution. So we still can have no solution when we are given 3 sides, even though it looks perfectly good here. Right. We will go to example B here, but and I skip that example. Instead of doing that example, we have to do example C. I'll make it up real quick. So triangle. Sorry. So still keep this one. If a little a is equal to 5, little b is equal to 7, and little c is 10. Now 5 plus 7 is bigger than 10. Definitely we have a triangle here. Right. So let's draw a triangle. Only know the size. Don't know the angle. Right. Obviously, when we see this, we use law of cosine. A is 5. So use law of cosine. And once again, we use the one with the biggest angle, which is opposite to the longest side. Which is c squared equal to a squared plus b squared minus 2ab cosine c. Right. 10 squared equal to 5 squared plus 7 squared. I said this is a bad idea when we put in the numbers. Obviously, we know little a, little b, little c. We just need to find the angle C here. So we subtract a square, b square on the other side. And then to solve for cosine of C, we take this, divide by negative 2ab. Right, I will store the numbers. Or not, this, it doesn't matter. Let's store the numbers. A is 5 store into A. 7 store into B. And 10 store into C. Right. A is 5, B is 7, and C is 10. I actually enter the formulas before, right? Oops, here. Negative 13 over 35. Right, we have the ratio. To get back to the angle, we check the cosine inverse or opposite. But we're not going to use the opposite in this case because we're working with a triangle and the angle cannot be negative. Cosine inverse of that. (118.8 degrees). Right. Next, we have a lot of choice. First, we can keep going using the law of cosine, doing this, and we can find any of the remaining angle. Or we can use the law of sine because we know big C, little c here. Actually, I'm just going to use the law of cosine with a different one. Now, let's solve for b. B squared equal to a squared plus c squared minus 2ac cosine of b. As long as b and b we good, the other two letters. Right. We know all the sides, just don't know the angle b. So we trying to solve for cosine of b. Subtract a squared and c squared. B squared, subtract a squared, subtract c squared, equal negative 2ac cosine b. So cosine b equal to b squared minus a squared minus c squared over negative 2ac. The reason I prefer to use this because we already store ABC into the calculator. We already do that. So it would be very convenient just to do this. B squared alpha B squared minus A squared minus C squared divided by negative 2AC 19.25. And then we find the inverse. cosine inverse of that. $40.5. Yeah, it's good enough. And then we can do the same thing. How to find the angle A. Let me zoom out for once. Right. And then we can solve for angle A the same way we did here. However, we just subtract from 180, get angle of A a lot easier that way. So A plus B plus C is 180. So angle A is 180 minus 40.5 minus 111.8. Right. $180 minus, oh, I have those numbers. That's the first angle, and then subtract. When I highlight the number, just go up and highlight the number, hit enter, and we'll copy and paste. 27.66, not 27.7. Right. Right. Once again, if there's a choice of using the law of cosine, I would go with the one with the biggest angle. That's just a reference. And after that, we can use the law of sine on the law of cosine. Yeah, because if you use the law of sine after the law of cosine, the law of sine, usually the ambiguous case, we have the sine inverse and the supplement to that. And I don't want to deal with that. Once we take care of the biggest angle, the other angle have to be acute. Right. So, that for now. And then let me zoom back in. Solve that triangle. That is angle A is given. Sine. Usually I put them. So in this case, B is here and C is there. Right. B is 15 meters. And C is 10 meters. Right, let's summarize. Big A, 115. Don't know B and don't know C. Don't know little a. We do know little b. And little c. Right. Oh, one thing I forgot. So we have to check, right? Biggest angle, longest side, smallest angle, shortest side. That check. Right. Now for here, we know that whatever A is have to be the biggest one for sure. Right. So what do we use? What should we use? And what can we use? Right. Cannot use the law of sine because we don't have opposite angle on side. So if law of sine doesn't work, law of cosine. But then even that, we have 3 of the law of cosine, right? So which one do we use? Well, it's not much of a choice. We only know angle A, so we obviously choose the one that have A in it. So this one. Right? So in this case, we know everything except we don't know A. So if A equal to B squared, 15 squared, this is A squared, not A, 15 squared plus B squared plus C squared, sorry, minus 2 times 15 times 10 times cosine of 115 degrees. (15 square plus 10 square minus 2 times 15 times 10 times cosine of 115. 451.789. Right. That is A squared in degree. Still good. Right. Now, this is A squared because if we put that in here, that side is way too big compared to the other two. We won't have the triangle if that is the case. So we just take the square root of that. Usually when we check the square root to solve for it, I put plus or minus. However, A is the sign or the measurement of a triangle, cannot be negative. So we just take it positive. Just use positive. 21.25255.6. Right. Next, what do we use? We can use the law of cosine or the law of sine. However, now since we have the pair of opposite angle and sides, the law of sine will work here. Sine of 115 degrees over 21.26 equal to sine of big B, we don't know big B, and over 15 sine of big C, we don't know, but we know little c. Right, so obviously we will take this ratio with this or this with the last one, cross multiply and solve for sine B. So we solve for sine B. That is 115, right? Yep, sorry. So 15 times sine of 115 divided by that number. Copy and paste. Shoot. The bad thing about a calculator is there's no undo option, so we have to delete. Right. Copy. I guess we already copy. Right. Copy. Right. Highlight this. Sorry, try to be lazy here. $21.255 255 Right, that will do. 0.6396. Right. Remember, when we do the inverse sine to find the angle, there's always two of them, right? The sine inverse and then the supplement. Right. So sine inverse $39.76. By the way, we'll not work on this case simply because in these scenarios, in this case, what we have is A is the biggest angle. If it is not the biggest angle, it can only be acute. Think about it. An angle that is not the biggest angle, it cannot be more than 90 degrees. So this is the only case we have. Don't even need to worry about this case. 39.76 degrees. And finally, subtract from 180, we have the remaining angle. So angle C is 180 minus A minus B (180) minus 115 minus 39.76 25.24. Right. Last check. Biggest angle, longest sine, smallest angle, shortest sine. So that certainly works. So that is what I mentioned before, where we use the law of cosine, find the angle. The first thing we do, we just go with the biggest angle first. Once we get to the biggest angle, when we use the law of sine, we don't need to worry about this case. is always that, right? Because if it is a smaller angle, it cannot be more than 90 degrees. So we exclude the other case already. Right. With that, we have, I forgot. With that, we finished section 7.1, 7.2, and 7.3. I think that will be enough for chapter 7. Right. I will end the video here. Thank you for watching. I hope you find this helpful.